This is Mayur. Welcome to ML Works. This is the third part of the computer vision basics. Here we'll cover features like corners and use the techniques like erosion and dilation for enhancing corners, and also we'll talk about something called as opening and closing technique for image cleaning and image enhancement. Okay, so in computer vision, one of the most common tasks is to perform object detection or an recognition. And for this task to be done, we need features to recognize those objects. For example, you have face detection. So what are the features of face? You have eyes, lips, a nose. All these are different features of your face. Okay, so there are algorithms which are what helpful in detecting these kind of features. For instance, there is hair cascade algorithm which helps in what identifying noses, eyes, and other such details. Okay, so similarly, there are like other what key aspects in your image which will be helpful for what detecting your object, and one among them is corners. Okay, so basically what happens is corner is, consider you have a square object. Okay, the top line, just I'll go back to the image. Actually, I'll load just an image which will make sense actually. Okay, so consider you have, what is corner actually? Consider you have this line on top, right? On the top, and the what one is horizontal line and the other is a vertical line. So two lines which are perpendicular to each other and intersecting at a point, right? That becomes your corner. So this corner will help us in what, one of the effective feature which will help us in what, detecting the objects in your image. Okay, so in this video what we'll do is we'll try to identify how to detect corners in your image and how to enhance or what, shrink those corners if required using erosion and dilation, and then we'll talk about what image enhancement or image cleaning. Okay, so first I'll just what I'll do is just we'll do with what corner detection. So what I'm doing is, in this cell, if you see, we are just importing the packages. One is OpenCV. For plotting, I'm what using matplotlib, and for numerical computation I'm using NumPy. Okay, so first what I'm doing is I'm just reading the image, which is, when I'm doing with OpenCV, it will be by default it will be reading BGR format. Okay, so BGR format is further converted into RGB here in this line using CVT color, and then further going down, right, we use what, RGB to gray. Okay, so for this video what we are doing is, for corner detection we'll be using some algorithm called as corner Harris algorithm. Okay, this is the one of the method which is directly implemented in OpenCV. So what we do is, once we have converted our image from what color image like RGB to gray, we can apply what corner detection on top of it. So what we do is we pass our grayscale image and we pass this block size of 2. Block size refers to what amount of pixels you want to pick for detecting the object. If you give a larger block size, you will have a larger corner detected. Okay, so and 3 is the kernel size. As I said earlier, right, what we have is this two edge detection is happening here, like vertical and horizontal one. Okay, these two edges intersecting at a point. For that what we do is something called as Sobel filter is present. A kernel size of 3 cross 3 is used, which is a Sobel filter which will detect the edges. The 0.04 is helps in what, avoiding generating the false corners for your image, and then what we do is we apply dilation on top of the corners detected. So what the dilation does is it tries to enhance or what increases the object size of your images by using neighborhood pixels. Okay, and next what we'll see is, since we have already detected the corners, we'll try to plot it out. Okay, so here what we do is, consider we have detected what corners. 1/10 of that value we take, right, the maximum 1/10 of the maximum value present in that detected corners, right, we create a threshold. Okay, so use that threshold as for what, plotting the points on your images. Okay, so here we can see we are iterating through each of the pixel values and measure if it is greater than threshold or not, and once if it is greater than threshold, then we keep it as what, 2550, 0, which is nothing but red color. Okay, so we can see in this image, right, all the places where there is corners present, like there is a what, perpendicular intersection of two edges. One is from what going from black to white, and here also black to white vertically and what horizontally. So this forms a perfect edge spot. So these are detected here. Okay, these are fine strong corners. So what we'll do is next we'll apply on top of dilation we have applied, right? Already we have done the dilation aspect. So we'll try to apply, or we try to visualize how the corners look when you apply dilation. Okay, so we have dilated image here and we are iterating. So we, for dilation also we have separate threshold which we have taken from here. So we find the maximum and then we do it by 1/10 of that maximum, and which will be our threshold dilation. Okay, so we iterate through our pixel points of the dilated image and do, if it is greater than what the threshold, then we turn it into what it's 255 comma 0 comma 0, again the red spot. So if we look at these two images, we don't see much of a difference actually. Okay, so they look similar even after applying the dilation. So what I'll do is next what we'll do is, since this is in what BGR format, okay, this looks in BGR format. Now we'll convert that into grayscale, gray mapping. Okay, so if we look in gray, we can clearly see here the edges detected. Okay, they look small, right? Small white spots here. But once we apply the dilation, these edges looks little what thicker, like increased the shape of our edge corner detection. All these corners here, they look what small white spots. Here they look bigger than what usually it is present. Okay, after applying the dilation. So it is, in a sense, what dilation does is it increases the size of the object which is getting detected. Okay, so now we'll talk about what dilation erosion. So erosion is nothing but, consider you have what white noise, you want to remove those noise. Okay, so we apply erosion for that. And generally what, when you have noise in your images, there is a process we follow called as what, first is erosion, apply erosion such that the noise is reduced, then we apply dilation which will increase the features of your objects present in your image. Okay, so that's what dilation and erosion represents. So let's check this one. So we have what chess image which is an RGB format, then we convert it into grayscale, and then we do what, apply iteration is equal to 2, and there is a kernel we are applying which is nothing but again a filter 1 cross 1 5. This is 1 of value 1 5 cross 5, that is 5 cross 5 matrix we have, and we are applying 2 times, iteration is 2, so dilation is happening 2 times on top of the image. So if we see, as I said earlier, dilation, what it does is it tries to enlarge the white spots or tries to enlarge the objects present in your image. So if we see here, all these corners got detected and it has been enhanced actually, and the size of your black, right, it reduces. Overall it has been reduced. The size of the square black is reduced. Overall white has been increased. Okay, so that is the point of dilation, tries to enhances your objects actually. And one, this is exactly opposite happens when you apply erosion. So let's see here, what we do is we do what, from again we take an image of a chess, turn it into RGB followed by grayscale, and we apply a kernel as earlier, as we did earlier. Then we use something called as erode, apply that kernel, and iteration is 2. Okay, so let's see how it looks like. Okay, so the erosion is also similar to dilation but exactly opposite. Okay, now the all the black objects are like have thick boundaries. Okay, because the white objects are shrinked because of erosion. Now if you want to what see how it changes, right, we can change the iteration to 4. So if you can see, right, the square again reduced, the black square is reduced here much more. And let's see here, I'll try to what, here the white spot will reduce. Yeah, see, so white spot is again getting reduced because of the erosion. Now next what we'll do is something called as opening and closing technique for image cleaning and enhancement. So if we see earlier in images, we have something called as these numbers here outside, so which are detected, right, 1 2 3, all these numbers we have. Okay, so these are kind of noise. If you want to consider that as a noise, if you want to remove that, what we can do is we can do something called as opening and closing technique, which will do an image cleaning and image enhancement. So let's apply that first. Now we have an image which we have what taken from here, like grayscale image. Okay, this is a grayscale image, and then we apply something called as opening technique with a particular kernel, the kernel which we have declared here. Okay, so once we apply that, let's see what happens. So since we are doing an opening technique, what it does is it does erosion followed by dilation. So it reduces the white spots, it reduces. Okay, so we don't have any white spots. Okay, it reduces the white spots and then enhances whatever that has been reduced, it enhances that. So we have what black spots here. Okay, that's what opening technique does. It is useful for what noise reduction, in which erosion first gets rid of the noise, that is shrinks the object, and then dilation enlarges the object again. Okay, the noise will have been disappeared. Okay, for it is useful for closing small holes inside a foreground objects. Okay, so this is just the definition of whatever I did right. Okay, so next is the closing technique. What we'll do here is it does dilation first followed by erosion. Okay, it is useful for closing the small holes or dark areas within an object. Okay, let's see how it looks like. So we have morphology X and erode gray image we take, then we apply something called as morph close and a kernel again, which is again a filter. Let's see how it looks like. So this is the original image, and these are our what you can call it as what noise if you want to call it. Okay, so we want to erode those things. So what happens is in closing technique we do dilation. Okay, so what dilation does is it enhances the object's white color spots, it enhances. Okay, in white color spots is enhanced, and then it is eroding that, followed by erosion. So those objects which are detected, those are getting eroded afterwards. So this is what we have done actually in this video. We have covered a bunch of stuff. First is features where we applied corners, Harris corner, something called as Harris corner detection, and then we do something called as dilation erosion on top of the detected corners, and then we apply opening and closing technique to image enhancement and image cleaning. And in the next video I'll be talking about segmentation using image contours, and for this video we are done. Thank you.